So we're talking about the mass on the spring, and I want to know if I want to make a clock out of a mass spring system, what mass and spring constant should we choose? Now, this is actually extremely common. This is basically almost always how we make clocks. We make clocks out of mass spring systems. They might be piezoelectric quartz, which oscillates like a mass on a spring. When you add a little bit of electricity, that's typically how electronic watches work these days, but the old-fashioned wind-up watches work with a mass and a spring. And so, this is not uncommon, unlike the grandfather clocks that work with a pendulum. So really the question is first of all, what do I mean? How do we make a clock out of a mass spring? Well, we want the mass spring, the oscillation, we want it to last a known amount of time. So let's say that we want it to be 1 second, right? We want the period to be 1 second. So if the period is 1 second, therefore, right, remember now that since omega is the square root of k over m, and omega equals 2 pi f, and f equals 1 over period, then therefore I believe that tells us that the period is 2 pi square root of m over k. Believe that works out. Hopefully I got everything up the right way. And so then it's a question of, well, if we're talking about a little tiny mechanism in a watch, maybe we're talking about a mass of, I don't know, let's just say a gram. If m equals 1 gram, 0.001 kilogram, therefore 1 second equals 2 pi square root of 0.001 kilogram divided by k. We want to solve for k, and what we get is therefore. So I went ahead and just solved for k by squaring both sides and then inverting both sides and then combining, and we get this, and I'm going to go ahead and plug that into my calculator. And what I get is that k is 0.039, and obviously it depends on how many digits, how accurate we want our clock to be, but anyway, 0.039 kilogram per second squared. And then you might say, kilogram per second squared? Well, k has units of newtons per meter. And you say, newtons per meter. Think about it. Newtons per meter, a newton is a kilogram meter per second squared. So a kilogram meter per second squared divided by meter is indeed a kilogram per second squared. So those units are correct. Those are correct MKS units, and that's what the spring constant should be.